Good morning to you all. So now we are going to start the equilibrium constant. So previously we have discussed up to the KP-Kc relation, that is the value of Kp and then Kc, and then for different cases, that is when delta Mg will be positive and then when it is negative means by the time what we get. So that and all we discussed up to the previous video session. So now we are going to start the equilibrium constant for heterogeneous equilibrium. We all know what is meant by heterogeneous. Here heterogeneous means the phases will get to be in different forms. Okay, so suppose here let us consider one equation. It is one reaction, calcium carbonate. Here this calcium carbonate is in solid phase. When we check with their product, calcium oxide and then carbon dioxide. Here calcium oxide is in solid phase and then carbon dioxide is in gaseous phase. See now the Kc value, that is the equilibrium constant, will be equal to the product concentration, that is divided by the reactant concentration. Okay. See now we have to write the Kc value will be equal to the concentration of carbon dioxide, or else simply we can write the Kp will be equal to the partial pressure of carbon dioxide. This P refers to the term partial pressure. Okay. See here, if we take the concentration of the pure solid, that seems to be very constant. Okay, so we have to check with the term carbon dioxide, because here the pure solid will have the same concentration, so it does not get expand to fill the container. So that is which means there will be the same number of moles per liter of its volume. So by the time we can confirm that the pure concentration, that is the concentration of this pure solid, will be constant, so that both this term will get neglected. So we have taken only the carbon dioxide. Okay. So then we'll take another example, carbon dioxide along with water. So here the product of it is H and then HCO3 minus. Here both in aqueous form. Okay, so this H plus as well as this HCO3 minus is in aqueous form, and then H2O in liquid phase, carbon dioxide is in gaseous phase. Okay, so now the value of this Kc will be given by HC. Kc will be equal to H plus aqueous, that is the product. We have to bring the product, that is divided by the reactant. So CO2 gaseous phase. Here if we check this H2O is a pure liquid. Okay, so it is a pure liquid. So that we have written for this both the term. Now here the example is given. Write the Kp Kc for the following. So any reaction if they given means the Kc will be given by the concentration of the product, then that is divided by the concentration of the reactant. They have to raise to their powers as their coefficient. Okay, so Kp means we have to put the term P. Okay, again for second carbon monoxide and also for the silver oxide and silver nitrate. The same step we have to follow. Now comes the application of equilibrium constant. See here, from the equilibrium constant, we can able to predict the direction in which the net reaction will take place, and also we can able to predict the extent of the reaction, and then we can able to calculate the equilibrium concentration of the reactant and then product. See, these are all the application of equilibrium constant. See, actually, this to be noted that these constants do not provide any information regarding the rate of the forward or else in the reverse reaction. Okay, so actually, these are all the this three refers to the application of this equilibrium constant. Using equilibrium constant, we can able to predict the direction and also the reaction extent, then the concentration values will be calculated for both reactant as well as for product. Okay, so these are all the application of equilibrium constant. See here, now let us take the first term, predicting the extent of your reaction. See here, if we take a value, that is the equilibrium constant value, the term Kc that tells about the extent of the reaction. So extent means how far the reaction will be proceed. So that we can tell under this. Here when the Kc value, that is the large value of Kc indicates that the reaction reaches the equilibrium with high product value. So Kc value large means then that indicates a high product yield. So low Kc value means then the low product formed. The product form will be lower. And here the Kc is greater than 10 to the power 3. So which means the reaction proceeds nearly to the completion. Suppose if it is lesser than 10 to the power 3 means then by the time we can say the reaction the proceed rarely. And if Kc is in the range of 10 to the power minus 3 lande 10 to the power 3 in the range irundhudana, then the amount of both the reactant as well as the product that should be in equilibrium. They both will be in equilibrium. So that we can predict under this. Okay. So these are all the major terms. See now here let us take the example over here. So here this refers to the dependence of the extent of a reaction on Kc. Here for different term. So இது எல்லாத்தையும் இண்டிவிஜுவலா வித் எக்ஸாம்பிளோட கொடுத்துருக்காங்க. So here Kc when lesser than 10 to the power 3, suppose 10 to the power 3 இந்த ரேஞ்சில் இருக்கும்போது அப்போ அதனுடைய ஃபேக்டர் எப்படி இருக்கும்? சப்போஸ் Kc greater than this 10 to the power 3 அந்த டைம் வந்து அதனுடைய கேஸ் எப்படி இருக்கும் அப்படின்றது தான் இங்கே கொடுத்துருக்காங்க. ஓகே, ஸோ ஃபஸ்ட்டு இதில் வந்து பார்த்தீங்கன்னா ப்ராடக்ட் கிரேட்டர் தென் ரியாக்டன்ட், இதில் ப்ராடக்ட் லெஸர் தென் ரியாக்டன்ட். ஸோ அந்த டைமுக்கு நம்ம ஒரு எக்ஸாம்பிள் பார்த்து அதோட ஸ்டேட்டஸ் எப்படி இருக்கும் அப்படின்றத we are mentioning over here. Okay, so now comes predicting the direction of the reaction. So direction அப்படின்றது அது ஃபார்வர்ட் ரியாக்ஷனா இல்லை பேக்வர்ட் ரியாக்ஷனா ஆர் எல்ஸ் இன் ரிவர்ஸ் ரியாக்ஷனா அப்படின்றத நம்ம டைரக்ஷனில் சொல்கிறோம். ஸோ நவ் த ஹோமோஜீனியஸ் ரிவர்சிபிள் ரியாக்ஷன் HCl plus YB will gives LC plus MD. So here this refers to the non-equilibrium reaction. See here this the term Q refers to the quotient. Okay, see here this quotient means that refers to the ratio of the product of the active mass of the reaction product that is raised to the power. So the power refers to the stoichiometric coefficient. Suppose if we mentioning is this in non-equilibrium condition, then by the time we can able to calculate the Q value. This Q is said to be the quotient here. Okay. See, suppose if the Q value will be equal to Kc means then that is in equilibrium state. Suppose quotient value is greater than Kc value oda அதிகமா இருந்ததுனா அப்போ அது reverse direction. Okay, product formation இல்ல reactant formation அது இடத்துல நடக்கும். இப்போ Q lesser than Kc means அப்போ that refers to forward direction. Then by the time there won't be the formation of a reactant, there will be the formation of product over here. Okay, so now here we can refer this example QC, Kc, and here also the different terms. Here this refers to the reactant, and here product equilibrium, and here this product to the reactant. Okay, see here the reactant gives product and here this is in equilibrium. ரெண்டுமே ஈக்குலிபிரியமா இருக்குது. இதில் வந்து ப்ராடக்ட் இது this blue color refers to reactant here. Okay, so இதுக்கு எக்ஸாம்பிள் ஒன்று பார்க்கலாம். The value H2, I2, HL. Okay, so இப்போ இதுக்கு Q value கண்டுபிடிக்கணும் அப்படின்னா we have to substitute their values and then கிடைக்கிற வேல்யூ வந்து பாருங்கள் அது நம்ம ப்ராடக்ட்டை விட அதிகமாக இருக்கா ரியாக்டண்ட்டை விட அதிகமாக இருக்கா அப்படின்னு கம்பேர் பண்ணுறோம். கம்பேர் பண்ணிவிட்டு ஃபைனலி வி கேன் டெல் த வேல்யூ இஸ் ஃபார்வர்டா இல்லை பேக்வேர்டா, அதை வச்சு அது ப்ராடக்ட் ஃபார்மேஷனாக இருக்கா இல்லை ரியாக்டன்ட் ஃபார்மேஷனாக இருக்கா அப்படின்றத நம்ம ஈஸியாக அதுலேருந்து ப்ரிடிக்ட் பண்ண முடியும்.